All right, so talking about polynomial functions of a higher degree. Yesterday we talked about quadratics, so the highest degree was a 2. Today we're going to talk about polynomial functions that have a higher degree, maybe to the 4th power or the 5th power. Graphically, we're going to go through this part quickly because I'm not going to give you any questions that you have to identify if it's a polynomial or not by a graph. But graphically, a polynomial function is continuous. Continuous means it doesn't stop if it has no breaks, no holes, or gaps. All right? Informally, not mathematically, but informally, if you just put your pencil on a graph and follow it along, and there's no breaks, there's nothing that you actually have to pick your pencil up and move it to the next piece, then that would be a continuous function. The functions that the graphs that I've given you on your last test and quiz was not a polynomial function because it had stuff like this, breaks and gaps and stuff like that. So a polynomial function will only have smooth, rounded curves. Do you guys see this? We call them sometimes peaks and valleys. It won't have any sharp edges. It won't have any like V's where it comes to a sharp stopping point and then goes straight back up or anything like that. It's always smooth, very smooth. The way that you can tell how many bumps or peaks and valleys are going to be in your graph is by taking the highest exponent and subtracting 1. And it's going to be the exponent number. So if you had like x to the 4th, blah, 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 and I said to you how many turns or how many bumps would be in your graph if you graphed it, you would tell me how many. There'd be 3 turns because the highest exponent is a 4, and you would say 4 minus 1. And we'll get to that a little more in a second. Like I said, if you had a function and it says, is this a polynomial, is it continuous? This would not be because it has a sharp turn. So that would not be good. Polynomial functions to the 1st degree are lines. To the 2nd degree are parabolas. 3rd degree, it's a cubic graph. 4th degree, it's a quartic. But as we talk about a polynomial function, we're going to find all sorts of things. We're going to talk about the end behaviors, what the graph looks like at the ends. We're going to talk about the zeros, like where it crosses the x-axis. We're going to talk about the shape of the graph and if how many bumps or turns it has. We're going to talk about the action at the x-axis. Does it cross through it or does it just bounce off and turn? The greater the value of n, the higher the exponent, the flatter the graph is near the origin. All right, so just some things. These are all things that you guys need to visualize because we're going to have to graph at some point. Just sketch a graph. So I want you guys to be able to visualize these things. Often referred to as power functions. If we have an even function, now when I say even, n is even. The highest exponent is even. The graph is similar to that of x squared, similar to a parabola. All right? Does everybody understand that? Like, think about that. If you have x to the 12th power, it's not a parabola, but it's going to resemble a parabola in the ends of the graph. If you have a parabola or something that is an even exponent, what do we think of when we think of even graphically? What do the arrows do? They go in the same direction, right? So if you have an exponent that the highest exponent in your function is even, the ends of the graph are either going to be both going up or both going down. We're going to talk about end behaviors in a little bit. If you have a function with the highest exponent is odd, 1, 3, 5, 7, then you know that the opposite ends of the graph are going to be going in opposite directions. If you want to think of a picture, think of a line or a cubic function. And we'll talk about that in a second. But just think about that. It's really important to understand the importance of the exponent, what it tells you so much about your problem. Now, we're not graphing this right now, right? If I had f of x equals x cubed, the shape of that is our little cubic function, like a snake, right? This is an odd number, opposite direction of the arrows. What does this negative in front of this x cubed do to that blue function? It flips it, so it comes like this. Do you guys see how the arrows are on the opposite sides? What does this plus 1 do? Moves it up 1, right? What does this minus 1 inside a parenthesis do? to the right one. Good. Okay, so good. Graphically, in your mind, you guys should see these things and think immediately, oh, up one, right one, flipped it over, something like that. All right, this is the leading coefficient test. This is the beginning of all the algebra that we're going to talk about today. Leading coefficient test. This guy, I promise you, when I first start to say it, you guys are going to be like, what? And then after I do a couple examples, it's going to really sink in. When you're leading coefficient, what does that mean? What's a leading coefficient? Okay, you're going to find the exponent, that's the highest. What's the leading coefficient? The number in front of it, right? If the leading coefficient is negative or positive, it means something. If the highest exponent is odd or even, it means something. So the first thing you're going to do is determine if the highest exponent is odd or even. If it's odd, meaning the highest exponent in your equation is 3, 5, 7, 9, something like that. Think in your mind what an odd function would look like. Think of a line. Think of a cubic. All right, I'm going to think of a positive line. You guys agree with me that a line slopes that way if it's positive. If your leading coefficient is positive, your end behaviors would be, this is the left, this is the right. You would say it's falling left and rising right. We're talking about what the ends of the graph are doing. Is it going towards negative infinity or positive infinity? It's falling towards negative infinity, and it's rising on the right towards positive infinity. You guys see that? If your function is odd, the highest exponent is odd, and it's a negative leading coefficient, then there would be a reflection. You guys agree with me? You kind of go like this. The opposite ends. Obviously, it's not a line, but we read end behaviors from left to right. So what's it doing on the left-hand side over here? It's rising on the left. And what's it doing on the right? Falling on the right. Good. Now, we're going to do a couple examples, and by the third example, you guys are going to be like, oh, this is easy, I got it. When the highest exponent is odd, this is a little tricky. When the highest exponent is even, it's super easy. Because if it's positive and it's an even exponent that's the highest, both of your arrows are going in the same direction. They're both going which way? Up. So you would say it's rising on the left, so rising left, and rising right. If you have an even, highest exponent is even, but it's a negative leading coefficient, what direction are both arrows going in? They're both going down. So you'd say falling left and falling right. All right, so you guys are going to get a question on the quiz. And it's going to give you a function. It's going to give you a polynomial. It's going to ask you, first thing it's going to probably say is how many turns. You guys say n minus 1. And then the next thing it'll say to you is describe the end behaviors. This is what it means. Now, on your web assign, guys, it's so imperative that you show work. Even if it's just writing an arrow that says write to or something like that. But just to acknowledge, this is a good way to show work. I'll show you exactly what I expect to see on a test or a quiz or on your web assign. If you have a question like this, and it says use the leading coefficient test to describe the right hand and the left hand, might say the end behaviors. All right, this is how we do this. The first thing we do is we identify the highest exponent. What is the highest exponent? 3. What kind of a number is 3? It's odd. When I think of odd, I think what? Opposite. Very, very reminiscent of our odd even neithers, right? So draw yourself a tiny, quick picture. An odd function has arrows going in the same direction or opposite? Opposite. Now I'm wondering which way. What kind of a function is this? Is it negative or is it positive? It's negative, so it's going to be sloping downwards. How many bumps would I have in this graph? 2, right? It's not going to look like a line. But just kind of visually see the ends. Excuse me. We always read and write end behaviors from left to right. So what's going on the left-hand side of the graph? It's rising left and what? Perfect. That's it. Now, some of you are going to want to do this all in your head, and I get it. But the problem with that is there is 0 partial credit I can give you for this. There's none. There's not a computation error. You didn't forget a sign or something like that. It's either you know it or you don't. So Make sure you guys are doing everything you can. I just showed you exactly what the easiest way to show you, visually show you what's going on and how to write it. Everybody with me? All right, so let's look at these little examples I have here. All right, this is a huge polynomial. How many answers should I have for this question? 12, all right? You're not factoring this, don't worry about it, but 12, right? There's 12 answers. How'd you know it's 12? Highest exponent, good. What kind of a number is 12? 12 is an even number, so I'm like, oh, good, this is even function. Not an even function, but an even exponent. When I think of even, what do I think about the direction of the arrows? The same, good. So I know that both of the arrows are going up, or they're both going down. So now I need to say to myself, well, which direction are they going? I look at that leading coefficient. What is the leading coefficient here? -3. So that means both of the arrows are going which direction? Downward. If you want to just draw a little parabola, that's fine. We'll look at something real quick. Okay. So we read end behaviors on the left-hand side, then on the right-hand side. So tell me what's going on the left. Falling left. And then tell me what's going on the right. Perfect. Good job, guys. Does that make sense now? You guys see that?
That's how we write it on the
Exactly like that, yep. If you want to write out the word left and right, that's fine. But you're always you have to list it from left to right, the way that we read a graph. If you switch them, you're going to get the answer wrong. So I'll look at number 2. We'll go through the same thing every time. The first thing I do is are we written in standard form? Yes. Let's identify the highest exponent. What kind of a number is 9? It's odd. So I think what? Opposite. Good. So think about it. Arrows are going in opposite directions. But what kind of a function is this? Is it even? I mean, is it negative or positive? So it's going to be sloping downwards. How many bumps would I have in this graph? 8. So it's not going to look like a line. But the direction of the arrows at the ends would be like that. There'd be 8 bumps in the middle of there. But if I read from left to right, the left-hand side and the right-hand side, what's going on the left? It's rising left and perfect. Very good. Questions? You guys are doing great. I know we're going fast. You guys are doing awesome. All right, what's the problem here? We're not in standard form. I'd get in the habit, guys, of rewriting in standard form. Remember, the sign in front goes with that term. So it's a positive 5x to the 7th. Don't just get hung up on the first number you see. You need to find the highest exponent. So the highest exponent here is a 7. What kind of a number is 7? It's odd. So I think opposite. Good. Now I look at the leading coefficient. Is this a positive or a negative? Positive, so it's going to be going upwards. How many bumps are inside of this graph? 6. But I know what the ends look like. So here's the end and here's the end on the left-hand side and the right-hand side. What's going on the left? It's falling left and perfect. Good job. Does that make sense? Everybody good? Any questions? No? Feel free to ask. All right, so now we're going to talk about, this is just so fun. I'm such a nerd. When we talk about real zeros, that word real means a lot. What do I mean by the real zeros, and what am I excluding when I say real zeros? We're excluding imaginaries. You might factor something and get x equals plus minus 3i. Is that included in my answer? Why not? Because it's not real. It is a 0, but it's not a real one. So you're going to have to really be careful. I'm going to ask for all the real zeros on this quiz, but on your test, because we're going to talk about imaginary stuff in a minute, not in a minute, but in a few days, you have to read the directions. If it says real zeros, I want just the real ones. If it says all of them, I want the real and the imaginary, so just pay attention. But we already talked about this, guys. We've talked about zeros, solutions, x-intercepts, roots, factors. What does all that mean? X-intercepts. How do I find those algebraically? You're going to set your equation equal to 0 and solve. 98% of the time, we're going to factor. Factoring is never going anywhere. So be mindful. Right now, we're talking about real zeros. We're going to get to the point where we're talking about the fake ones, those imaginary ones. So just pay attention to what you're doing. If I have a question like this, all right, you're going to get a question like this. It's going to ask you end behaviors, zeros, multiplicity, action at the x-axis. Once we talk about our zeros here, then we'll talk about all the other stuff that I just talked about. But the first thing I want to do is say, all right, if I was going to graph this, how many bumps would it have? I'd have 2, right? What would the end behavior look like? Well, what kind of a function is this? It's an odd number, so I know my arrows are going in opposite directions. Is my leading coefficient positive or negative? So it's going to be going similar to that. So what's going on the left-hand side of my graph? Falling left and rising right. Good job. So the second part of the question would be like, okay, well, what are the zeros? That means I say x cubed minus x squared minus 2x equals 0. How many answers should I get here? 3. They may not all be real, but I should get 3 answers. When we factor, guys, what is the first thing we look for? GCF. What can I take out of all 3? So take out your x. I have x squared minus x minus 2. Good. So x. What do I have left here? What can I factor? Negative 2 and positive 1. So I have x equals 0, x equals 2, and x equals negative 1. Everybody agree? Set each piece equal to 0. Do I have 3 answers? Yes. So this function, if I were to graph it, I know that the arrows are going in opposite directions, right? So let's think about this. I know they're going in opposite directions. I know I have intercepts at 0, negative 1, and 2, right? Was it a positive? So I know that the arrow is going to be down here somewhere and up here somewhere. And then I know how many bumps am I going to have? You guys told me 2, right? So it's going to go something like this. Boom, 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 right? Now, something happens at the x-axis when you have something called multiplicity. And we'll talk about that in 1 second. But you guys should be able to visualize all this stuff. You should be able to say, okay, the ends of my graphs will do this. Where is it going to touch the x-axis? How many bumps should I have along the way? All of these things should be coming to your mind when you do these problems. Because now we're going to talk about something called multiplicity. What does it mean to have multiples of something? I have multiples. Right? More than one. I had 2 kids at one time. 2 for the price of 1. So multiples. If you have more than, the same thing more than once. So if I have x equals 2 and x equals 2 versus x equals negative 3, x equals negative 3, x equals negative 3. Both of these x values, both of these answers have multiplicity. Do you understand what I mean by that? I factored something out in my mind and I got x equals 2 times. I solved something else and I got x equals negative 3 times. Everybody understand that? Okay. This multiplicity would be how many times? 2 times, okay? This multiplicity would be how many times? Okay, perfect. Everybody with me? When you have an even number of multiplicities, even number, you have the same number twice. You have the same number 4 times. You have the same number 6 times. Everybody understand what I mean by that? At this point on the x-axis, here's my graph, here's 2. My graph is going to what's called touch and turn or bounce. When you have an even number of multiplicities, your graph at the x-axis you can say touches and turns, or you can say it bounces off the x-axis. Either way is fine. It doesn't go through that point. It touches it and changes direction. If you have multiplicity like we have here, an odd number of times, meaning you have the same answer once, you have the same answer 3 times, you have the same answer 5 times, an odd number of multiplicity, your graph at the x-axis crosses through it. So it would look like this. Say I have -3 here. How many times do I have -3? How many times did I write it? 3 times. So it would go something like this. It would come through. It might come back somewhere else, but it's actually going to cross through that point. So if you have the same answer 2 times, 4 times, 12 times, if you were to graph it at the x-axis, it would hit that x value and turn the other way, bounce off of it. If you have the same answer, if you have an answer 1 time, 3 times, 5 times, an odd number, it's going to cross through at the x-axis. Does that make sense? Okay, so now we're going to kind of put all of this together. You'd have a question on your test quiz that says, here is this. You're going to tell me all this stuff, and you're going to sketch the graph. So you're going to have to tell me how many turns, the end behavior, the zeros, if there's multiplicity, what's happening at the x-axis. So action at x-axis. And we're going to draw a tiny little graph. Quick little graph. You don't have to memorize this. I will have lines that say end behavior, zeros, multiplicity. Yes, ma'am. All right, here we go. First thing we're going to do is I'm going to say, how many turns is this graph going to have? How many is it? 3. You take n minus 1. You say 4 minus 1, the highest exponent. So it's going to have 3 turns in it. That's important to know when we have to graph. Now we're going to determine the end behaviors. Well, I look at the highest exponent, which is a what? A 4. It's an even number. When I think even, I think same direction. So draw yourself a little picture. Is this a positive 3x to the 4th or a negative one? Positive. So I know that both of the arrows are going up. So on the left-hand side, what's my end behavior? On the left-hand side, what direction is it going? It's rising on the left. And what's it doing on the right-hand side? Rising on the right. Good. I know it might seem silly to draw this little picture and circle the arrows, but it really helps. It really does. Now to find the zeros, guys, how do we find the zeros? Set the equation equal to 0. So 3x to the 4th minus 4x cubed equals 0. How many answers should I come up with? 4. They may not all be real, but I should come up with 4. So as we go to factor this and to solve it, what do I take out? I take out x cubed, right? And I'm left with 3x minus 4 equals 0. All right, when I solve, I have x cubed equals 0. 3x minus 4 equals 0. How do I solve x cubed equals 0? Take the cube root. Okay, so the cube root of 0. What number times itself 3 times gives me 0? Okay. Now here I'm going to add 4. You guys agree? And then divide by 3. So I get x equals 4/3. How many answers do you see? How many did you tell me I should have? What did I miss? What number times itself 3 times gives you 0? It's not plus or minus, but how many zeros do I really have? I have 3. Because we took the cube root, right? I like what you guys said. Would it be plus or minus? What about if I had x squared equals 0? If you solve this, you would take the square root, right? And you'd get x equals 0 again. But how many zeros do you really have? 2, because what would we put in front of here? Plus or minus. There is no plus or minus 0. But understand, guys, when you take a root, like a cube root, a 4th root, you have that answer more than one time. If you need to write out x equals 0, x equals 0, x equals 0, so you see it, that's fine. If you don't need to, that's fine. But notice how I got my 2 answers, and I was like, okay, I got 2. Wait, I should have 4. Go back and look and see if you missed something. So you would state here for your zeros, you would tell me x equals 0, and x equals, was it 4/3 or 3/4? Okay, 4/3. Do you have to write 0 3 times? No. The reason you don't is because the next question is there multiplicity, or state the multiplicity? Do we have multiplicity, guys? Yeah, you do. You have multiplicity how many times? 3 times where? At x equals 0. That's how you guys would answer that question. You tell me 3 times, 2 times, 8 times, whatever, and where. Do I have multiplicity at x equals 4/3? No, I only have it once. So now you have to describe the action at the x-axis. Well, think about the multiplicity. If it's an odd number of times that you see the answer, it does what? Crosses through. Good. If it's an even number of times you see the answer, it does what? Bounces. So what happens at x equals 0? It crosses through. At x equals 0, you can say crosses through. If you want to write me a paragraph dissertation, that's fine as well. I don't need all that. What happens at x equals 4/3? It crosses through. You will have answers where at one answer it touches and turns, the other answer it crosses through. Just the nature of the beast. But if you guys were going to give me a little graph. All right, this is what you can expect to see on your quiz next week. You have one question that's going to ask you all the stuff about vertex and x and y intercepts, all that stuff. Then you're going to have a question that says this. Find the real zeros. We're still talking about real, and I'll put real in the directions. But you're going to answer all of these questions using one function. So I look here, and the first thing I say is, how many turns does this thing have? 2. Where'd you get 2 from? N minus 1. So 3 minus 1, there's 2 turns, 2 bumps. Let's talk about the n behaviors. What kind of a number is 3? It's odd. So odd means opposite. I should see this sort of stuff on your web assign when you do your homework. I should see this sort of stuff on your test. This is an odd function. It's not an odd function. That's an odd power. Is this a positive or a negative function? So it's going to be going upwards, correct? Something like that? So what's the end behavior? What's going on the left-hand side? It's falling left and doing what? Rising on the right. Good. Now, how do we find zeros, guys? Set the equation equal to 0. We're going to have to factor here. So you have x cubed plus x squared minus 4x minus 4 equals 0. First thing we look for is a GCF. Is there one? No. So now we group. 4 terms, we got to group. So I take out an x squared. Agreed? And then I'm left with x plus 1. What do I take out of the next one? Negative 4. Very good. And I'm left with x plus 1. Agreed? So I write my x plus 1 time out in front. And then what happens with x squared minus 4? It gets its own parenthesis. Good. Do you have to break down x squared minus 4 anymore? No, because you're going to solve and you'll get the answer anyways. My suggestion to you is to, because some of you will solve x squared minus 4 and tell me x equals 2. Is it just 2? It's plus or minus. So I would go ahead and say, okay, this breaks down to x plus 2 and x minus 2. So what are your zeros? What does x really equal here? Negative 1, negative 2, and positive 2, right? Okay, so you have your x's. You can just write x equals negative 1, negative 2, positive 2. If you want to write x equals, that's fine. Do you have multiplicity? Do you have the same exact answer more than one time? No, you have no multiplicity, none. Understand that negative 2 and positive 2 are two very different places on the graph. So if you have no multiplicity, or if you have each answer just one time, think about what 1 is. 1 is an odd number. So is it going to touch and turn at the x-axis or cross through? It's going to cross through. I told the first period when I was writing these notes, I don't know if I was listening to Cardi B or something. I don't know. Not sure what happened there. But it's going to cross through at the x-axis. So if you had to graph this would be an easier one to graph. All right, you have your 3 intercepts. You have one at -2, -1, and +2, right? What did we say the ends of the graphs are doing? It's falling on this side and rising on this side, right? And then how many bumps should we have? 2. So I have a point here, a point here, and a point here. What is going on at each one of those points? Does it touch and turn or does it go through? So it'd be like boom. Oops, I missed it. It'd be like this. It's not going to be perfect. None of your graphs are going to be perfect, but you should be able to visualize what is happening in your graph. Does that make sense? We okay? All right, scooting along. Same thing. Hopefully this is a little better than when I first started. How many turns should this thing have? 4 turns, okay? N minus 1 is going to give me 4 turns. End behavior. What kind of a number is 5? It's odd, so opposite. Positive or negative? Okay, so it's going to go something like this. So tell me the end behaviors. What's happening on the left? Falling left. Good. So falling left and rising on the right. Good job, guys. Very good job. Now we're going to find the zeros. Help yourself out here. How many answers should I get? I should get 5. Are they all going to be real? Maybe, maybe not. When we are factoring, when we're solving, the first thing we look for is a, okay, what can I take out of 2x to the 5th and negative 32x? Perfect, very good. So that leaves me with x to the 4th minus 16. Agreed? Okay. Can I break that down? X squared and x squared plus minus 4. Agreed? If you want to break down more, you can, but does x to the x squared plus 4 break down? It doesn't, you're right. X squared minus does, but the plus doesn't. So let's set each of these equal to 0. 2x equals 0. Divide by 2, divide by 2. I get x equals 0. Is that an okay answer? Yeah. So here I have x squared plus 4 equals 0. X squared equals negative 4. Take the square root. What happens here? I get x equals plus minus 2 what? I. Are those 2 viable answers? Yes. Are they real? So do I include them in my answer? No. Good. And then over here, I have x squared minus 4 equals 0. So I add 4 to both sides to get x equals 4. Take the square root, and I get x equals what? Plus or minus 2. Did I get 5 answers? Yes. Are all 5 of them real? No. So the only ones I care about right now are the real ones. So I would say x equals 0, x equals 2, x equals negative 2. Somebody's going to ask, can I write plus minus 2? Yes. I just think it's a better idea at the beginning here for you to write positive 2 and negative 2. So you don't write plus minus 2 and think, oh, I have 2 twice, because you don't. Do we have multiplicity here? Nope. So what's going to happen at the x-axis? It's going to cross through again. You will have an instance, guys, like we had in the first example, where you have multiplicity at one point and not at another. You might have where it touches and turns at one point and crosses through at another. That's okay. All of that's okay. But do you guys see how all of this is all intertwined? So much can be said about a polynomial function by just looking at the highest exponent. If it's a positive or negative leading coefficient, you can tell how many zeros you have. You can tell the end behaviors. You can tell almost if there's multiplicity. You guys will get to have it. You'll start to see patterns and stuff. All right, we okay? All right, the next part, last part. This is easy, I promise. I'm not going to get through all of them. We'll just get them set up. And then I'll work through a couple of them and then on the video, and then we'll work on these when we get back. Yes, ma'am. All right, this is going backwards, right? We are used to starting out with x cubed plus 3x squared minus 5x plus 7 equals 0 and solving it. Here, they're telling you what the zeros are. When it says find a polynomial with the given 0, they're saying here are the answers. The answers are x equals 3, x equals -4, and x equals 1. We are going to work backwards. We're going to combine all this together and find out what the original equation looked like. So how do we do that? Well, set up your parentheses. If I take positive 3 and I move it to the other side of the equal sign, what does it become? So x minus 3. If I take -4 and move it over, it becomes what? X plus 4. And if I take positive 1 and move it over, I get x minus 1. And now we just FOIL, guys. Keep one of your parentheses. Leave it alone. I always leave the first one. But FOIL two of them together. X times x is x squared. X times -1, -x. 4 times x, 4x. And 4 times -1, -4. So when I combine like terms, God bless you, I get x squared, what? Plus 3x minus 4. You guys agree? And now we just multiply again. So I'm going to take x to everything. So x times x squared is x cubed. X times 3x is plus 3x squared. X times -4 is minus 4x. -3 times x squared is -3x squared. -3 and a positive 3x is minus 9x, right? And a -3 and a -4 is plus 12. And then we combine like terms. You should always start off your function with f of x, g of x, h of x, whatever letter of x you want to do. But I have x cubed. What happens with a positive 3x and a -3x squared? God bless. They cancel. Good. -4x and a -9x. Perfect. And then what? And there's your answer. At the beginning, should you have known what the highest exponent should have been in your problem? No. Why? Because there's 3 answers. Good. Good. Now, guys, understand, I know that most of you can just look right from here and put it in parentheses. I just think it's best to do that first little step that I wrote, x equals, because how easy is it for you to just put x plus 3 in a parenthesis, x minus 4 in a parenthesis, and x plus 1? FOIL it out, and that's completely wrong because the signs are wrong. If you have something like this where you have one of the x's as x equals 0, x equals -5, and x equals -7, if you were to move this over, this becomes x plus or minus 0, right? You don't have to write that 0. You can just put an x in front of your parentheses and FOIL it in later. But what would this parenthesis look like? X plus 5, right? And this one would be x plus 7. So you would have something like this. And you would just multiply it all together. Keep the x on the outside. What's x here times x? X squared. What's x times 7? 7x. And then what's 5 times x? 5x. So 5 and 7 is 12, right? And then 5 times 7 is 35. Good. So now take that x and distribute it in. I have f of x, g of x, h of x, doesn't matter, equals x cubed plus what? 12x squared plus 35x. Perfect. So all you're doing is just going backwards. I give you the zeros, you're going backwards. Nothing really changes if you have roots, not a big deal. Is the square root of 3 a number? Yeah. Is it a beautiful number? No. Okay, guys, so this one, I forgot one of the roots. I meant to write it. But when you have a square root, you have to have the root and its conjugate, or its opposite. So you have, hold on one second, I'm doing a video for school. So you have x equals -1, x equals +1, x equals square root 3, and x equals negative square root 3. So when we go into our parentheses, I have x plus 1, x minus 1, x minus square root 3, and x plus square root 3. So I'm going to go ahead and FOIL in the x plus 1, x minus 1. So x times x is x squared. X times negative 1 is negative x, positive x. And then negative 1 and positive 1 is going to be negative 1. Those x's will cancel out. So I'm left with x squared minus 1. So over here, we're going to take our x's. X times x is x squared. X times positive root 3 is x root 3. Negative root 3 times x is negative x root 3. And then negative square root of 3 and negative square root of 3 would give you negative square root of 9, which is just the whole number 3. These middle terms cancel, so we're left with x squared minus 3. And now we're going to go ahead and FOIL those together. So x squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. Negative 1 times x squared is minus x squared. And negative 1 times negative 3 is positive 3. So now when we combine like terms, we're going to have our f of x, g of x, whatever you want to call it. But you have x to the 4th. Negative 3 and a negative 1 is going to give you minus 4x squared. And then we have plus 3. And there's your polynomial. So again, here we have 3 answers, 3 roots. These are my 3 roots. I have x equals 3 minus root 2, x equals 3 plus root 2, and I have x equals negative 6. So if we create our 3 parentheses, bring this over, it becomes x minus 3, and we distribute that negative, so plus root 2. Bring this one over, I have x minus 3, distribute the negative minus root 2. And then bring this over, this becomes x plus 6. So let's FOIL these first 2 together. So x times x is x squared. X times negative 3 is minus 3x. And x times negative root 2 is minus x square root 2. So now I have negative 3 times x is negative 3x. Negative 3 and a negative 3 is plus 9. And negative 3 and a negative root 2 is positive 3 root 2. And then lastly, we're going to take our root 2. So root 2 times x is x root 2. Root 2 and negative 3 is minus 3 root 2. And then negative root 2 and a positive root 2 is minus the square root of 4, which is 2. I'm making a video for school, honey. Give me 1 second. So if we combine like terms, we have an x squared. Oops. We have x squared. I have a negative 3x and a negative 3x gives me minus 6x. My negative x root 2 and a positive x root 2 cancel. So we have 9 minus 2 gives me plus 7. And then 3 root 2 and negative 3 root 2 cancel out. And then we have our x plus 6 here that we're going to FOIL in. So x squared times x is x cubed. X squared times 6 is plus 6x squared. Negative 6x and x is negative 6x squared. Negative 6x and 6 is minus 36x. And then I have 7 times x is 7x. And 7 times 6 is 42. So when we combine like terms here, I have x cubed. Well, actually, I should write it like this. I'm going to use my f of x first. But I have x cubed. Negative 6x squared, a positive 6x squared cancel. Negative 36x and a 7x gives me minus 28x. And then I have plus 42. And there is our polynomial. So now the last one, we'll get this all set up. You guys see we have 4 roots. So I have x equals 2, x equals negative 3, x equals 1 minus root 7, and x equals 1 plus square root of 7. So when we set this up, same thing. We're going to go through this. I'm going to bring my 2 over. This becomes x minus 2. Bring this negative 3 over. It's going to become x plus 3. When I bring this over, it becomes x minus 1 plus root 7, x minus 1 minus square root of 7. So we're going to go ahead and FOIL the first two together, and then we'll FOIL the second two together, and then we'll combine those two. So x times x is x squared. X times 3 is plus 3x. Negative 2 and x is negative 2x. Negative 2 and positive 3 is minus 6. So we combine like terms. X squared plus x minus 6. Please excuse the concert going on in my house. My daughters are playing with their little cousin. So x times x is x squared. X times negative 1 is negative x. X times negative root 7 is minus x root 7. Negative 1 times x is minus x. Negative 1 and negative 1 is plus 1. Negative 1 and negative root 7 is plus root 7. Root 7 and x is plus x root 7. Root 7 and negative 1 is minus root 7. And root 7 and negative root 7 is minus square root of 49, which is the whole number 7. So let's combine like terms. We have our x squared. Negative x and a negative x is minus 2x. I have a negative x root 7 and a positive x root 7. They cancel. I have a positive root 7 and a negative root 7. They cancel. So you have 1 minus 7 gives me negative 6. And now we multiply again. X squared and x squared gives me x to the 4th. X squared and negative 2x gives me negative 2x cubed. X squared and 6 minus 6x squared. X and x squared gives me plus x cubed. X and negative 2x gives me negative 2x squared. X and negative 6, negative 6x. And lastly, we're going to take negative 6 and x squared, so negative 6x squared. Negative 6 and negative 2x gives me plus 12x, and negative negative gives me plus 36. So now I'm going to combine like terms and finish this problem in this video for you guys. So I have x to the 4th. Nothing else has an x to the 4th. I have a negative x cubed and a positive x, negative 2x cubed, and a positive gives me minus x cubed. I have a negative 6x squared, a negative 2x squared, and a negative 6. So 6 and 2 is 8, and 6 is minus 14x squared. I have a negative 6x and a positive 12x, so plus 6x, and then I have plus 36. And that, ladies and gents, is your problem.